Hi guys, welcome back. Today we'll be talking about forces and dynamics. And the forces we're talking here is not the kind of force that you do, like you understood in Star. Okay, so let me just continue. So we're gonna go through some forces that I noticed. So yeah, so later we'll go through forces and we'll go through the dynamics problems too. Actually. Okay, so these are some types of forces with gravitational, tension, normal, friction, drag. So these two are very similar, and the normal force is always perpendicular to the surface. So let's say you have a wall here, and you have a person here, let's say someone like JY is pushing on the wall. The normal force is in this direction. Okay, so continue. So this is we can actually resolve these factors by splitting it into components, like splitting it into different components, right? These are component factors. And they're exactly the same if you put it on two directions. And this is the same thing. And we'll talk about trigonometry later on because you have cosine and sine. I'm just going to debug about it a little bit. So in the right angle triangle, let's say this angle is called theta. This side called the opposite side because it's opposite to the angle. This side is called the hypotenuse, and this is the adjacent side. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite by adjacent. Okay, so just a little bit on trigo. So now move on to Newton's first law of motion. A continuous still rest or uniform motion in a straight line unless a resultant external force. It can be friction. So if there's no resultant force acting on an object, it will either remain at rest or continue to move with a constant velocity in the same direction as it was moving originally. You can see in this picture, this object has no resultant force on them, so it will remain at rest, and it will continue at constant speed and direction unless exerted by unbalanced force. So the Newton's second law of motion states that it's equal to the acceleration and mass of the object, and we can derive the formula such that the net force is equal to mass times acceleration. Newton's third law of motion states that whenever one object exerts a force on the second object, the second object also exerts an equal and opposite force on the first. For every action, there's equal and opposite reaction force. And we'll be going through some problems later on so that you can understand Newton's law of motion. But now, for now, let's move on to the other topics. So we can derive this that FP equal negative this because it's some equation, but don't have to worry about this one a lot. And this means that they must be equal in magnitude, opposite direction, same nature, and acting on two and cannot act on the same body. So we're going to talk about friction, kinetic and static friction. Friction is the force that opposes the motion between surfaces in contact. When we try to move a box, we notice that it takes more force to get started than to keep it moving at a steady speed. So this is why we have two types of friction. One is called kinetic friction, the other one is called static friction. Static means not moving. And kinetic friction equals to the coefficient of friction times normal force. We'll talk about the coefficient of friction later. So except static friction, in almost all cases, they're less than the static friction. Let me just draw you a nice graph that what will it look like is look like this. Let's say, oh, your static friction increases, but it's not moving, and it decreases, and this is your kinetic friction. So this is your kinetic friction, and this is your static friction. It's a graph, okay? So now viscous forces in a liquid fluid. Yeah. So experience a resistive force called drag, which is given by this formula, and D is the constant based on shape, size, and fluid density. And v squared is viscous speed, and terminal velocity is vt, which is when in vt, this is the mg, the gravitational force equals to the air resistance of the ground. So later in the question will be talking about it. So yeah, this is what it looks like. Its terminal velocity, then it'll be equilibrium. So let's try our first question. But before even attempt, I have to tell you something, that this angle is theta. It's my bad. And this angle is theta. And basically that I want to find the applied force acting on the object. Okay, pause the video and solve your own. And if you can't, you can continue watching. If you can, you finish it, and I hope you get it correct. Okay. This is a question, right? So how do we solve this question? I'm going to use the figure that we had previously, but right, this is the figure that we have previously. I'm going to write down and help you do some calculations. So we have to draw a free body diagram of this, but how do you draw the free body diagram? Okay, so this is the gravitational force as we write it as Fg acting on object. We also have a normal force acting on the object, which is the normal force. So we capitalize the G. And then we have opposing force, which is the frictional force. What else can you find? These are the only forces that are available, right? That is actually true. And if we look at the accelerator, we know that we have to use a formula F equals to ma. So let's start. Firstly, the gravitational force can be resolved with two other vectors. These are two vectors. So, and we have to find this angle, which is theta. So, because since this is a theta. And so over here, this is sine, right? We get it is Fg sine theta. And at this side is Fg cosine theta. So in order to find, we can say that the Fa, right, is equivalent to what? We have a frictional force and we have a assisting force of Fg sine theta, like that. And we can easily get Fg, which is, so we can write down here, Fg is equals to mass times acceleration, which if we use a calculator to calculate that I have here, that I'll show you the results. So if we look at it, it's 69 times 9.81, which is equal to 676.89. For simplicity, we'll put it to 677 newtons. And since it is accelerating down, that use the F equals to ma formula to do it. So the force applied, the total force net is its mass, which is 69 times 2 meters per second, which in this case gives us 138 newtons. Sorry, right. And we want to find the answer for this. So this is a clue. So if you can't solve it, this is a very nice clue. And I hope that you can pause the video again to see and how to solve the problem. So give you 5 seconds to think about it and we'll continue. Okay, welcome back. So we'll be talking about that question again and continuing the solution to the problem. So now you know that these two are the components of the force Fg. So you can see that the Fn, which is the normal force, right, is equals to the Fg cosine theta. And that is a fact. It is fact. Just real quick for me to just erase this part because I just told you that it works. And it is the formula because it's not going just accelerating down. Okay, so now we have solved partially. Let's continue solving this question. So let me just use my calculator and let's calculate Fg cosine theta. So on my calculator, which is on my computer, and just see. So Fg, which is equal to 677 cosine theta. Right, so this is 677 sine theta right there. Very nice, right? And so we can say that the F net is equals to the mg, which is our Fg sine theta minus applied force minus the friction. We should write it as Fk. And this is equals to Ma. And we know that since we say that the coefficient of friction, my bad, is that Fk is equals to the coefficient of friction K times the normal force, which is the coefficient of friction of the kinetic movement and mg cosine theta. So we substitute into Newton's second law to get mg with sine theta minus Fa minus the coefficient of kinetic friction times mg cosine theta is equal to Ma. So eventually we simplify this. Just gonna erase, it's kind of cluttered, right? So we'll just erase the useless info, not this. Just for info, I guess. Over here, stuff like that. So the overall solution to this problem is plugging the values to get this. Let me just write it down. Sorry for the picture there. Is Fa equals to 69. Don't ask me why, times 9.81 sine theta minus 0.69 times 9.8 cosine theta minus 2.0. If you don't understand this, I bet this is times. Yeah, so basically this formula. If you don't understand this, you can search it online or go to websites to learn more about this, and you can comment to this later. So now we move on to the next question. A 73 kg police officer is suspended by two cables as shown. First one, sketch a free body diagram of the police officer. Well, it's not that bad, right? So, and find tension in each cable. So, pause the video first and solve the problem. Then we'll come back to it. Okay, great. So I hope you have solved the problem. So now I'm going to show you how I approach and solve this problem. So first I'm going to draw the free body diagram of the police officer. So firstly, this is gravitational force, which is equals to mg. And then we have tension 1 on the table. So force of tension and tension from 2, and this is what the FBD looks like. So now to find the tension. So the net, just is the system's in equilibrium. The net is such that tension of the second cable cosine 48 right of 48 is equal to T1 right cosine 35, and then cosine 35 degrees, and the net force on y is T1 sine 35 and plus T2 sine 48, T1 sine 35 plus T2 sine 48 degrees equals to the downward force, which is calculated by 73 times 9.8, which gives us 715.4. So this is 715.4. So we solve for T2 is equals to T1 times cosine 35 over cosine 48 degrees, which is equals about T1 times 1.2247. Then plug into y direction and find that T1 is about 482 newtons, so T2 is about 409 newtons. To the question. It's generally easy compared to the other question we solved just now, so hope you understood it. Next question. If a person pushes a stationary 125 Newton boxer force of 75 Newton at an angle of 30 degrees below the horizontal, so it looks like this in the figure, as shown in the diagram. The closure separation between the box and horizontal floor is 0.8, and they tell us to find A, B, C, D, and E. So let's pause the video and think about it for a little bit before continuing. Okay, so this is our question to Lil be helping you solve this question, right? So it looks kind of complicated, but actually the answers are quite simple. First, the only thing that we have to do is the only hard thing is that we have to draw the 3-point diagram. So it looks like this. So this is our block. We apply a force of 75 Newton, 30 degrees to the horizontal like this. So we have a weight acting on it, 125 Newton, a normal force acting on it, applied force, 75 Newton, at 30 below the horizontal, which is over here, which can be split into two parts, a horizontal component and a vertical component. Right, so what the horizontal component is 75 cosine 30 degrees, and the vertical component is 75 sine 30, which is acting downward. And also we have frictional force opposing the intended motion. So like this. Okay. Now we find a normal force. Normal force. Well, the normal force is equal to the weight plus the vertical component of the force, which gives us 125 plus 75 sine 30 degrees, which is equals to 125 plus 75 times 0.5, 25 plus 7.5, which gives us 162.5 Newton. That's the answer for me. Okay, good. So now we have 162.5 Newton, and we can continue with that. So 160.5 newtons. So now the friction acting on the block. The friction is equals to the force of the horizontal component, which is 75 cosine 30 degrees, which is equals to about 64.95 newtons. That's our answer for C. And then for D, what is the largest value of friction, which is use the coefficient of friction to solve it. Maximum friction, we call it Fmax, is equals to the coefficient of static friction and our normal force that we calculated just now equals to 130 Newton. Then for E, we have the person who places a pool at angle of 30 above. Find normal force acting above in this case. So again, normal force equals to W minus F. Y, just the vertical components, equals to phi minus times pi sine 30 degrees, which equals to 5.6. Okay, so this answer for each of the questions are not that hard. It's actually quite easy. It's all one-liners. And yeah. Next question. I think that's our last question. In certain circumstances, the average distance on a falling person can be modeled to be proportional to the square of the person's speed. Given that the proportionality constant between the average distance and the square of the speed is 0.1 kg per meter, determine the terminal velocity of 60.0 kg per person as the average distance when the person's speed is half the terminal velocity determined in A. So pause the video to solve yourself first, and we'll continue. Okay, I hope you have solved the problem. So let's start solving the problem. The terminal velocity is in terminal velocity, right? This case, the gravitational force is equals to the velocity squared, and by the way, the FD is equals to the average distance. Since mg equals to dv squared t, we can determine vt is equals to mg over d, which is equals to 588 over 0.10. And with the help of the aid of this, we get square root of 5880, which is about 76.8 meters. And that's our answer for the first question. 76.8 meters per second. And for B, the average is in half, so V is equals to Vt divided by 2, and which is 38.4 meter per second. So Fd, which is that equals to dv squared, which again is equals to about 118.48 Newton. And yeah, just about that. Okay, great. So I hope that you can solve this problem. It's not that hard again. It's quite easy. So yeah. And that's the end of my presentation. Thank you for watching. I hope you have learned from this video. Thank you. I hope you can subscribe.